This is section 12.5, multiplying and dividing rational expressions. When you multiply fractions, of course, you're going to multiply across the numerator and the denominator. So our basic parent function here is a divided by b times c divided by d equals ac divided by bd. Of course, here b cannot equal 0 and d cannot equal 0, or the function would be undefined. And an example with numbers here is x plus 2 divided by x times 3 divided by x squared. So you just multiply straight across the numerator. So you have 3 times the quantity x plus 2, and that's divided by x to the third. This cannot be simplified, so just leave it like that. When you divide rational expressions, however, you have to multiply by the inverse. So in this example, we have a divided by b divided by the function c divided by d, and that's the same as a divided by b times d divided by c, and that equals ad divided by bc, where b cannot equal 0 and c cannot equal 0. If you look at the example here, we have x divided by x minus 1 divided by 4 divided by x, and that equals x divided by x minus 1. And now you're going to multiply by the inverse of the second fraction. So you're multiplying by x divided by 4. That gets you x squared divided by 4 times the quantity x minus 1. And again, you can't simplify this, so just leave it like that. The simplest way to multiply and divide rational expressions is just with monomials, that is with one term in both the numerator and the denominator. So here are two examples. In example A, we have 2x squared over 3x, and we're multiplying it by 6x squared over 12x cubed. So multiply the numerator straight across, so you get 12x to the fourth, and in the denominator you get 36x to the fourth. But here you have common factors in both the numerator and the denominator. That is, the 12 in the numerator and the 36 in the denominator reduces to 3 in the denominator, and then you have x to the fourth in both the numerator and denominator, so you can just knock that out completely. So the answer here would be 1/3. In the second example, example B, you have 7z squared over 4z cubed times z cubed over 14z. Again, multiply straight across here. So it's going to be 7z to the fifth. Remember, when you're multiplying exponents, you add them. So 7z to the fifth divided by 56z to the fourth. This reduces down to z over 8. This is going to get a little more complicated multiplying polynomials. The easiest way to do this is to factor the polynomials first and then combine all the terms in the numerator and all the terms in the denominator, and then eliminate the common factors. So in the first problem we have 3x squared plus 3x over 4x squared minus 24x plus 36. And we're going to multiply by x squared minus 4x plus 3 over x squared minus x. So the first thing you want to do is factor both terms. After I factor them and combine the numerators, I end up with 3x times x plus 1, that's from the first term's numerator, times x minus 3 times x minus 1, that's from the second term's numerator. And then in the denominator, I removed a common factor of 4 from that first term, so I get 4 times x squared minus 6x plus 9. And that's multiplied by x minus 1 times x. Okay? Then you can start eliminating the common factors. So if you see you have the x in the numerator and the denominator, that can disappear. The 3 and 4 stay where they are. In the numerator we have an x minus 1, and in the denominator we have an x minus 1, so those two are eliminated. So now in the numerator we have 3 times x plus 1 times x minus 3. And if you look at that term in the denominator, that polynomial can be factored again. So it ends up to be 4 times the quantity x minus 3 times the quantity x minus 3. That was a perfect square trinomial. And these x minus 3's can disappear. You can knock those out. So you end up with 3 times x plus 1 over 4 times x minus 3. Here's another example, but this time we have a fraction multiplied by a binomial. So we have 5x divided by x squared plus 5x plus 6, and I'm going to multiply that by x plus 3. So the x plus 3 just goes in the numerator with the 5x, and I've factored the denominator so that it's x plus 3 times x plus 2. So now I have a common factor in the numerator and the denominator, the x plus 3 and the x plus 3. Those you can eliminate, so you end up with 5x divided by x plus 2. That is in its simplest form. You can't remove anything from either the numerator or the denominator. Dividing is a little more complicated because, of course, you have to flip everything around. So in example A, we have 7x squared minus 7x over x squared plus 2x plus 3. And I want to divide that by x plus 1 over x squared minus 7x minus 8. Remember, division is multiplication by the inverse. So I'm going to flip the second term over and multiply. That's what I've done here on the second line. Okay, so all I did was turn that term upside down. When I multiply across there, I get 7x times x minus 8 over x plus 3 because I've eliminated all the common factors. So pause this for a second and take a look at that to see how I did that. In B, I have 2x squared plus 16x plus 24 over 3x squared, and I want to divide that by x plus 6 by a binomial. Again, you're going to multiply by the inverse of that binomial, so you're going to multiply by 1 over x plus 6. In the first fraction, I took out a common factor of 2, so that I get 2 times x squared plus 8x plus 12. And then if you'll see on the next line, I've actually factored it more completely so that it's 2 times x plus 6 times x plus 2. In the denominator, we have 3x squared, but I've multiplied it by x plus 6. Okay, that's where we get this term down here. So when you take a look at that, you now have common factors in the numerator and denominator of x plus 6, so those you can eliminate. So we'll just knock those out. So you end up with 2 times x plus 2 all over 3x squared. The last thing in this section is using all this multiplication and division to solve a multi-step problem, a real-world problem. So what we're going to look at is the amount A in millions of dollars spent on all the advertising, and the amount T in millions of dollars spent on just television advertising in the United States during the period of 1970 to 2003. And what they did was they found out that could be modeled by these two equations. You see the A is the total amount of advertising, and the T is the amount of advertising just for television. And this only covers the years 1970 to 2003. So anything outside that time window, these equations will not apply. They want you to write a model that gives the percent of the amount spent on all advertising using the television advertising numbers. Okay, and then they want you to approximate the amount spent on television advertising in 2003. So remember what percent is. Okay, you're going to take the part of the advertising divided by the total advertising. So you're going to take the equation for T and divide it by A. So down here you can see, since you're dividing, you're going to multiply by the inverse. So I just took the two equations that were given earlier in the problem and found that the percent is 1800 plus 860x all over 1 minus 0.016x, and I want to multiply by 1 minus 0.015x all over 13,000 plus 3700x. To solve this, you have to factor and divide out all the common factors. So I multiplied straight across, and then I'm taking out the 20. In the top term and the bottom term, both the numerator and denominator have a 20 in them, so you can remove the 20 from both. So even though the formula is still really complicated, it's not as complicated as it was, so it's going to be easier to solve. In part 2, you want the percent that's spent on television advertising. That's spent on television advertising in 2003. 2003 is 33 years since 1970, so you have to use an x of 33, and you're going to substitute it in the equation that we've developed here. You can see how a lot of things can go wrong here. If you multiply incorrectly in these beginning steps, you're going to have an incorrect equation here, and then when you start to plug in the numbers for the years, everything's going to go wrong. So if you take a look at the percent down here now, I've used the 33. You can see where it's going. Everywhere there was an X, I plugged in 33, and then I multiplied it out. Of course, you have to use your calculator to do this. And I ended up with 0.239. So that's approximately 24% of the amount spent on all advertising was spent on television ads in 2003.